in Chapter 8.2, and it's systems of linear equations in 3 variables. Here are our objectives. So let's begin. So in general, any equation of the form ax plus by plus cz equal to d, where a, b, c, and d are real numbers such that a, b, and c are not all 0, is a linear equation in 3 variables. So that just tells us we have 3 variables. Instead of dealing with an x and y, we got an x, y, and z. A solution of a system of linear equations in 3 variables is an ordered triple of real numbers that satisfy all equations of the system. The solution set of the solution set of the system is a set of all its solutions. Okay, so your solution is going to look like an x, comma y, comma z. If you plug the x, the y, and the z in, the left side of your equation will equal the right side. That's what it means to satisfy the equation. So let's go to page 813. Let's look at number 1. It says determine if the given ordered triple is a solution of the system. So the triple they gave us was 2, negative 1, 3. And we have the system x plus y plus z equals 4. And then we have x minus 2y minus z equals 1. And then the last one is 2x minus y minus 2z equals negative 1. So we need to verify that this ordered triple is a solution, or if it's not a solution. So everywhere we see an x, y, and z, we're going to plug in 2, negative 1, and 3 respectively for each equation. So we're going to start off by saying, well, 2 minus 1 plus 3. Does that equal 4? Well, 2 minus 1 is 1, plus 3 is 4, so 4 equals 4. So it works for the first equation. Let's check the second. So now it's 2 minus 2 times negative 1 minus 3. Does that equal 1? And remember, all we're doing is substituting the x, the y, and the z. So that's going to be 2 plus 2 minus 3, which is 1, and that does equal 1. So it works for the second equation. And then the last equation, 2 times 2 minus negative 1. Be careful with the minus sign and the negative sign. Minus 2 times 3. Does that equal negative 1? So that's 4 plus 1 minus 6. And yes, that is negative 1. So negative 1 equals negative 1. So it works for the third equation. So this is a solution to this system. Alright, so now let's keep going. Recall in 9.1 and 9.2, we started talking about using our calculators to solve systems of equations. So since we're dealing with a system with 3 variables, we can solve it using the substitution method and the addition method. But since it has 3 variables, I like to go ahead at this point and start using our calculators. So let's go over the steps for inputting a matrix into your calculator. So the first thing you need to do is get inside the matrix menu. Now, depending on what kind of calculator you have, for example, this is the 83 plus. Ignore what's on the screen. To get inside the matrix menu, we hit second, x to the negative 1, y, because there's the matrix in yellow. If you have an 83, you should have a button that just says matrix. You should be able to click on it, and it should take you inside. And then, of course, you're going to scroll over to edit, then hit enter, and type in your matrix. And these are the same steps from 9.1 to 9.2. So I won't go through the steps. Instead, let's look at an example problem. So let's look at page 813, and let's look at number 5. It says solve each system. So we have x plus y plus 2z equals 11. And then we have x plus y plus 3z equals 14. And then we have x plus 2y minus z equals 5. So the first thing we have to do, since we're going to be using our calculator, is write this system as an augmented matrix. So we end up with 1, 1, 2, 11. And if you don't recall what an augmented matrix is, please go back to 9.1 and 9.2. This is why we do 9.1 and 9.2 first, so we can introduce our calculators and matrices. So when we get to systems that have more than 2 variables, we can fall back on our calculator. So then the second row is 1, 1, 3, 14, and then 1, 2, negative 1, 5. So this is our augmented matrix. So let's get inside our calculators now, and let's input this matrix. So go ahead and to get inside my matrix menu, I hit second x to the negative 1. Some of us may have calculators where we just hit the matrix key. Once you're inside the matrix menu, scroll over to edit and hit enter. You're inside matrix A now. So now you need to tell them the dimensions. Well, how many rows do we have here? We have 3 rows. And how many columns? 4 columns. So it's a 3 by 4. So type 3, enter, 4, enter. Now you're to the point where you can input the elements for your matrix. So we have 1, enter, 1, enter, 2, enter, 11, enter. And go ahead and fill in the rest. Once you've inputted this last element, so you hit 5, enter, at that point you should be able to use your cursor keys to scroll up and down, left and right to check your elements. Make sure everything's good to go. Once you are satisfied with your matrix, go ahead and hit second, quit. Now we need to get back inside our matrix menu. So go ahead and get back inside your matrix menu. Once you're back inside, scroll over to Math, and then you can scroll all the way down to RREF. So on your home screen, it should say RREF with an open parentheses. Now you need to get back inside your matrix menu, and you should be under names. Now I always deal with matrix A, so at this point I just hit enter. And on my home screen, I see RREF and then a matrix A. Go ahead and hit enter at that point, and you receive the following output. And remember, your last column represents your constant, so you know that you have this vertical bar here. Okay, so if you were to write out our solution, remember the first column is x, the second is y, and the last is z. So it says x equals 2, y equals 3, and z equals 3. So that's the solution to the system. It's the triple 2, 3, 3. If you were going to solve this by hand using the addition method, you would have to work with 2 equations at a time. So we could work with the first 2 equations, and we could subtract them, right? Therefore, we eliminate the x's and the y's, and then we can solve for z. Then you have to move down and work with another pair of equations. So you could work with the second equation and the last, and again you can subtract them, and again you're going to still eliminate the x's, but this time you'll leave a y in terms of z. So you'll be able to solve for y. So actually, let's work this out by hand. So the first 2 equations, I'm going to subtract them. So x plus y plus 2z equals 11. And I'm going to subtract x plus y plus 3z equal 14. So remember, this negative goes to each piece. It changes the signs, right? So the x's will eliminate. The y's will eliminate, and then we'll have 2 minus 3, which is negative z, equals 11 minus 14, which is negative 3. So z would be equal to 3. So now we're going to work with the last 2 equations. So again, we're going to subtract them. So we have x plus y plus 3z equals 14. And then we have x plus 2y minus z equals 5. And remember, we're only subtracting them because I want to eliminate the x's, which means I need their coefficients to be the same values but opposite signs. This is a positive 1, and I need this one to be a negative 1. So I'm basically multiplying by a negative. So my x's eliminate, and then I have 1 minus 2, which is negative y, and then I have 3 minus negative 1, which is plus 4z, equals 14 minus 5, 9. Okay, but I already know what z is. It's 3, so let's input that. So we have negative y plus 12 equals 9. So we end up with y equals 3. And then the last thing to do is take the y and the z, plug it into any of these equations, and solve for x. And you should come up with x equals 2. Okay, so you can either do it by hand, or you can use matrices and your calculator. Alright, let's look at number 17. So now we're still solving the system, and this time we have a system that looks like 3 times parentheses 2x plus y plus 5z equals negative 1. And then we have 2 times x minus 3y plus 4z equals negative 9. And then the last equation says 4 times 1 plus x equals negative 3 times z minus 3y. So before we can even solve this system, the first thing we need to do, we need to have our x or y and our z on the same side, and only, which is the left side, and only constants on the right side. So let's go ahead and distribute, and let's start moving things around. So distribute the 3 on the inside, and this becomes 6x plus 3y plus 5z equals negative 1. We're going to go ahead and distribute the 2, and we get 2x minus 6y plus 8z equals negative 9. And then for the last one, we're going to distribute the 4 as well as the negative 3. So I'm going to do that work down here because I have more steps to do. So it's 4 plus 4x equals negative 3z plus 9y. Now I need to get the x, the y, and the z on the same side. So I could subtract 4x on both sides. And I end up with 4 equals negative 4x minus 3z plus 9y. So I can write it as negative 4x minus 3z plus 9y equals positive 4. And this becomes our system. So now we can write out our augmented matrix, and it should be 6, 3, 5, vertical bar, negative 1, and then it's 2, negative 6, 8, negative 9, negative 4, negative 3, 9. Oh, we made a mistake, as in I made a mistake. What was my mistake? I need to make sure that my x's, my y's, and my z's are lined up, correct? So let me rewrite the last equation. So it's negative 4x plus 9y minus 3z equals 4. So let's do that again. So negative 4, 9, negative 3, positive 4. Okay, so once you have your augmented matrix, go ahead and input it into your calculator. So get inside your matrix menu, scroll over to edit, and then hit enter. This has 3 rows and 4 columns, so it's a 3 by 4. And let's go ahead and input this into our calculators. Once you have it inputted into your calculator, make sure you do second quit to get out of the matrix. And now you want to get back inside the matrix menu. Scroll over to math and down to RREF, which is row reduced echelon form. Get back inside your matrix menu. You should be under names. I always deal with matrix A, like I always say, so I just hit enter. And I hit enter one more time. Enter the first time, inputs matrix A here. Enter the second time, gives you your new output. And what do we have here? We have 1, 0, 0, 0.5, so I'm going to write it as a half. And then we have 0, 1, 0, and it's 0.3 repeated, and we should know that that's a third. And then we have 0, 0, 1, and negative 1. So you can have fractions, it's possible. My matrix looks a little sloppy, but that's okay. So let's write out our solution. This is x, y, z, correct? X column, y column, z column. So we're saying x is equal to a half, y is equal to a third, and z is equal to negative 1. So your order triplet would be a half, comma, a third, comma, negative 1. And again, you can solve this by hand using the addition method. For this case, let's say we wanted to eliminate the x's. In fact, let's say we wanted to eliminate the y's. And we will start by looking at two equations at a time. To eliminate the y here, we would have to, this entire equation will have to be multiplied by positive 2. And then you would add these equations. And then you would pick two more equations and try to eliminate the y's again. So we could use the first and last, which means in that case we would multiply the first by negative 3 because that's a coefficient of positive 9. Add them, and then you will have to continue this elimination method. Alright, last one, number 19. It says find the quadratic function y equals ax squared plus bx plus c, whose graph passes through the given points. So I know the graph passes through negative 1, 6, 1, 4, and 2, 9. Now remember, these are points, so they represent an x, a y. So the first thing you're going to do is input the x and input the y. So for the first equation, we end up with 6 equals a times negative 1 squared plus b times negative 1 plus c. Clean it up and you should have 6 equals a minus b plus c. Input the x and the y for the second and you get 4 equals a times 1 squared plus b times 1 plus c. So we have 4 equals a plus b plus c. And then for the last, we have 9 equals a times 2 squared plus b times 2 plus c. Clean it up and you have 9 equals 4a plus 2b plus c. Now I'm going to switch my equal sign on the other side. Six, 4, 9. Okay, so here's your system of equations, which means we're going to solve it using our calculator, or you can solve it by hand, your choice. So first thing you're going to do is get your augmented matrix. This time, instead of using x, y, and z, we're using a, b, c. So the first coefficient is a 1, a negative 1, 1, your vertical bar, and then 6. And then we have 1, 1, 1, 4. And then we have 4, 2, 1, 9. So let's go ahead and input this into our calculator. So get inside your matrix menu, scroll all the way over to edit and hit enter. This is a 3 by 4. Let's go ahead and enter these values. Make sure you're hitting enter after each element. So you would start with 1, enter, -1, enter, 1, enter, 6, enter, 1, enter, 1, enter, 1, enter, 4, enter, and so on. Once you have done the last element, which is 9, enter, at that point you should be able to use your cursor key to scroll left, right, up, down, etc. Go ahead and check your elements were entered properly, and then second, quit to get out of the matrix. Now, get back inside the matrix menu, scroll over to math, and scroll all the way down to RREF, which is row reduced echelon form. Second, get back inside your matrix menu. This time you are in names, and go ahead and hit enter. So it should say RREF matrix A. Hit enter once again, and you get the following output. So 1, 0, 0, 0, 1, 0, 0, 0, 1, and then we have 2, -1, 3. So then the solution would be A equals 2, B equals -1, and C equals 3. So if we go back to their function, we're going to substitute the A, the B, and the C. So we have y equals 2x squared minus x plus 3. And there's your quadratic function. Alright, so this will conclude the video for 8.2. Please email me if you have any questions.